What if you could slow down time, not in science fiction but in real space? Black holes don't just swallow light and matter, they also bend space, and warp time itself. In this video we'll explore how black holes can make time slow down, and what that means for space, science, and possibly even time travel. A black hole is what remains when a massive star collapses under its own gravity. All of its mass is crushed into a point of infinite density called a singularity, surrounded by a region called the event horizon, a point of no return. But black holes don't just suck things in, they also distort the very fabric of space and time. This phenomenon is called gravitational time dilation, and it's not just theoretical, we've observed it. According to Einstein's theory of general relativity, gravity isn't just a force, it's a curvature in space and time. The stronger the gravity, the slower time moves relative to someone in weaker gravity. So near a massive object like a black hole, time doesn't flow the same way as it does on Earth. To someone watching from far away, a clock near a black hole appears to tick more slowly. The closer you get to a black hole's event horizon, the slower time moves, from an outside perspective. If you hover just above the event horizon for a few hours, years, or even centuries could pass for everyone else. In theory, if you could survive the immense gravity, you could use this to time travel into the future, by simply experiencing less time than those far away. You may remember the movie Interstellar, where the astronauts land on a planet near a supermassive black hole called Gargantua. There, 1 hour on the planet equals 7 years for people outside. That's not just Hollywood, it's based on real physics. And scientists like Kip Thorne helped ensure the depiction was scientifically accurate. In real life, we've measured similar, but less extreme effects here on Earth. Time dilation isn't just a black hole thing, it happens here on Earth too. Satellites in orbit experience weaker gravity than we do on the ground, so their clocks tick slightly faster than ours. That difference is tiny, but GPS systems need to correct for it to stay accurate. It's a real-world demonstration of how gravity affects the flow of time. Black holes don't just warp time, they warp space too. Imagine space-time as a stretchy fabric. A black hole creates an incredibly deep well in that fabric. Objects fall toward it, and time too gets stretched. This stretching becomes infinite at the event horizon. From the outside it looks like anything approaching a black hole freezes in time just before crossing the boundary. But for the object itself? In theory, yes. If you wanted to skip ahead in time, spending a few hours near a black hole could let you fast forward into the distant future. But the risks are enormous. The gravitational forces could crush you, radiation around the black hole could fry your spacecraft, and getting there would take massive amounts of energy and time. Still, it's one of the few physically possible forms of time travel known today. Black holes are more than just cosmic monsters, they're windows into the deepest workings of the universe. They show us that time is not absolute, that your experience of time can change, depending on where you are in the universe. And that reality is far stranger and more beautiful than we ever imagined. Thanks for watching, stay curious, stay cosmic.